Joining me for another video. Today I want to look at deception technology, what it is and why you might want to consider investing in it. So, the malicious actor's objective is obviously to get to your prized assets, whatever those may be. They could be jewels as shown here, intellectual property, it doesn't matter. For every company and every individual, you have something of value. All right, you would have to have something of value, otherwise hackers simply are not going to waste their time trying to get into your organization. Now, typically when they get in, they don't come in with a loud marching band making a lot of noise and alerting you of their presence, right? So their whole modus operandi is one of stealth. Get in, remain stealthy, and spread, right? They're looking for how they can get into the various assets in the most clandestine way possible to make off with the treasure trove that they are seeking. Now, deception as a defense is the whole idea of making something look too good to be true, right? So opening up a portal, if you want, an avenue that will draw them in, making them believe that they finally cracked the code to get into your treasure trove. So it's about laying down these breadcrumbs. Now, the concept is not new. Things like honeypots have been around for a long, long time. But modern deception technologies have moved on considerably from where honeypots basically left off. And the whole thing is to draw them in and neutralize them as and when they fall for the breadcrumbs. Now, let's look at the challenge from the network perspective. And to understand why deception technologies are so important, we need to understand what it is that the bad guy is leveraging when they get onto your network. So let's just recap how machines communicate with each other over a switch network, and it's exactly the same with a wireless network. Machines do not talk at the IP layer on the same broadcast domain. So broadcast domain can be a flat bridge network or can be a VLAN, it doesn't matter. But fundamentally, machines talk at the MAC layer, the layer 2 of the OSI model. So you see here I've got two machines with two MAC addresses. Obviously these are bogus MAC addresses for the purposes of the video, but it's irrelevant, right? The concept remains the same. The machine on the extreme left will send an ARP, an address resolution protocol. So the machines will obviously have IP addresses, and the machine on the left will send out an ARP, and it'll say, who has this IP address? Please give me your MAC address. Now, the way a switch network works is that ARP, that broadcast traffic, is then flooded out of every single port. And finally, it'll get to the machine that has the IP address, and that machine will then respond with its MAC address. Now, what's happening in the interim is that the switch is learning these MAC addresses. It's learning the ports. When the machine on the left sends that ARP request, as part of that ARP request is not just the destination IP address and the destination MAC address, it also contains the source MAC of the machine that sent the broadcast traffic. And the switch learns this, which is why switches are sometimes referred to as learning bridges. And it stores that in what's called a CAM table, a content addressable memory table or MAC address table. So now it knows that, say for example, the machine on the left is on port 1 and the machine on the right is on port 4, for example. Now what it then does with this CAM table is it switches packets directly between those two machines. All right, that's why it's called a switch. Anything ingressing on port 1 destined for port 4 is switched directly between those ports. Now from a security perspective, it doesn't matter that you've got a firewall sitting northbound, because the firewall doesn't see this traffic. As we've just discussed, this traffic is directed. It's direct switching. So it doesn't matter how powerful the firewall is, what features and functions it's got, if it can't see the traffic, it's blind. There's nothing it can do about it. So you may ask, well, why didn't I just put in network taps? Well, of course you can do that, and network taps do have value, but there's something to consider here is that for a network tap to work, we need to span the traffic. A network tap is either put in inline or it's put on what's called a span port. All right, and a span port basically takes a mirror of all the other traffic and sends it to the tap to analyze it. Now, a couple of things come in here. One is called head of line blocking. If that span port is on a 1 gigabit port, and I've got 48 1 gig ports all chatting to each other, I've effectively got a 48-to-1 oversubscription ratio. Now, what that means is that not all that traffic is going to be able to go up that link. And what's going to end up happening is we're going to end up with false negatives. The link is so busy that not all the mirrored traffic can get to the tap, or at least can't get to it in time. And then we have another problem, which is called the serialization delay. How much traffic can the CPU on that tap actually process in any given amount of time? And again, we're opening up the window for false negatives. The false negative is when an occurrence happens, but the device that's meant to be detecting that can't see it because it's either overloaded or because the traffic never gets there in the first place. And the other thing to consider with network taps is that they're typically using signature matching. All right, they're looking for your virus signatures, web filters, IPS signatures, things like that. They are static and typically out of date when it comes in terms of a 0-day threat. A 0-day, in other words, a threat that's never been seen before. Static signatures are no good. Now, that's, as I said, that's not to say that a tap doesn't have value. It does. I'm just pointing out here that it also has limitations. The same holds true for network detection and response. Now, network detection and response is on another level because now it's using machine learning and AI. But it also is still subject to the head of line blocking. All right. It doesn't matter. Even if we put a 10 gig port there, at some point you're going to end up with a saturation layer. The other thing to think of, though, is that an NDR works primarily by trending, creating a baseline, looking at traffic, trending what is normal, and then looking for anything that's now abnormal. So yes, it's looking at behavioral anomalies. So it's better than a tap, which is based on static signatures. But what happens if by the time you've put the NDR on your network has already been compromised? You don't know it, all right? So now what the NDR is baselining is actually not just normal traffic, but as far as it's concerned, the hacker traffic is normal as well because it's the first time it's got on the network, it's baselining it, and that's all the traffic it sees. So it doesn't see an abnormality. And this is why deception technology is so important. Remember that hackers are looking for that low-hanging fruit. They don't want to spend too much time on your network because the more time they spend there, the greater the chance that they're going to be detected. Now, if we can lure them in, making them think that they have found that holy grail, and we can do it in such a way that we can gather more intel about them because we don't immediately block them off. We drip feed them. Feed them a little bit like Hansel and Gretel, little crumbs. We can spread those crumbs around, not just on the actual deception platform itself. We can spread the love to all the individual machines or different machines on the network so that each machine becomes part of the deception environment, if you will. And then the machines, your normal PCs, which again they have got these little tokens, these little breadcrumbs, these little lures, they are redirecting that traffic back to the deception platform. And that gives us a bigger picture. And once we've got a bigger, more rounded picture of what the hacker's really doing, now we can take informative action to deal with the threat. And as I said, that's not to say that the other technologies don't have a place. All these technologies have a place in the context of a layered security, right? No one thing is perfect. Things need to work together as a fabric, sharing intel, sharing their capabilities. But the purpose of this video is specifically to look at the deception technologies. So I'm going to shoot across here to my FortiDeceptor. And we can see that I've got 31 lures. So a lure is a bogus machine, right? So it's bogus environments which are left wide open to make the hacker, to draw the hacker in and make them believe that they've found something. All right, so if I come along here, I can look at my decoy and I can see that I've got a Linux server running. All right. And I can also drill down here and I can see the various services that I've got running on here. So Samba, all that stuff you saw on the dashboard. All right, I've also got various users with very generic username and passwords. These are the sorts of things that a hacker is going to use password crackers like Jack the Ripper to jump on. All right, and it doesn't take them long, and they're going to find this. And again, it's going to entice them to try and get more out of this machine, believing that it is truly a wide open machine. Right? Again, the Samba has got various usernames, my HTTP, and so forth. Now, as I said, so we can have these things called deception tokens as well. I haven't actually got any deployed here, but the concept here is that we create a campaign and we have a whole lot of these little these crumbs, these breadcrumbs that we distribute out to actual machines on the network, which make the wide open environment seem more attractive to the hacker than it really is. Now, I integrate this with the security components, right? So I need to be able to take action on the bad guy when I find him. So what I've done in this instance is that I've integrated my FortiDeceptor with a FortiGate firewall. All right, now you can see here I'm using a webhook. Now, I've actually got different ways of doing this. I could integrate this directly with the Fortinet fabric. All right, now if you don't know what the Fortinet fabric is here, if I come along to my fabric, I've got fabric connectors. And this is what I said about the sum of the parts, about these things working together, is that I can incorporate many components within the Fortinet product portfolio to work together to share intelligence and to take real-time action upon a threat. And actually, it's a multitude of actions that can actually be taken, which I'll show you shortly. All right. And here I could have added in the FortiDeceptor as one of these tools, but I have chosen, and the reason will become apparent a bit later on, to use a webhook rather than using the direct integration. Right now, as I said, there's many different ways. I could use the REST APIs. I could use all sorts of things to integrate. And this is for examples of where potentially we are using non-Fortinet products. All right, so we can take in feeds from different products and we can have actions or push actions either from or to those devices and the FortiDeceptor. Now, once it detects something, it will then activate this webhook, and it'll tell the FortiGate to quarantine that device. Now, the webhook in this case is part of something called the automation script. So here you can see I've got two here, FTC web. Again, I'm told it to ban the IP address, and then I've also got an unblock here to take remedial action at the end. So once the threat has been looked at, maybe it's been deemed to be a false positive, and then the administrator can unblock it, or we can put a timer on it so it unblocks automatically. So let's just go along and run a potential attack. Now what I'm going to do here, just for the purposes of simplicity and of time, I'm going to just do a scan on the machine, right? So let's just go back and revalidate that. So let me come along here, look at my decoy status, and we can see here that the IP address of the decoy is on this IP address 253. It's actually on the same subnet as this Linux machine. All right, you can see there. Okay, so in fact, let's just make things 100% clear. If I do an ifconfig here, I can see that this machine is on the same subnet, 201.220. All right, and I'm going to do a scan on 253. Now what I'm going to do in the meantime, or rather simultaneously, is I'm just going to run a ping in the background so we can see traffic going there. And just put in my password. All right, so now I'm running a scan. So now the thing with the FortiDeceptor, it's not going to be an immediate thing because the FortiDeceptor needs to look at what's happening. It needs to ascertain that it's genuinely an undesirable behavior, because what you don't want is it just to do a knee-jerk reaction and just block traffic without doing any sort of verification and validation, because otherwise what we could end up doing is actually using this, or rather a bad guy could end up using this as a conduit for a denial of service. In other words, blocking genuine traffic on the network, which wouldn't serve the purposes of the environment in any way, shape, or form. So just let me just go back here. So now, if I look here, while I was talking, I've now got 56 events which have come in. So let's drill down into those events. And we can see here that indeed it was a port scan, all right? That, there was my attacker IP address, which was the IP address of my machine. And we can see everything that was happening. Now, if we come back to the machine here, we can see that my ping has actually stopped. Now, it stopped because the attack machine has actually been quarantined. There you go. So I use that webhook. It's an auto quarantine state. And if I come across here to this machine and I look under my quarantine status, there it is. Okay, so I can see that that's been banned. So that received the webhook from the FortiDeceptor and blocked this machine. Now, I've got FortiClient in the background here, and you may wonder, now, why have I got that? Okay, now you can see FortiClient has lost, unsurprisingly, has lost connection with the EMS, Enterprise Management Service. Now, it's lost connection because it's lost outbound access. Now, think about this. Think about that the hacker has now been detected, all right? Maybe it's an infected machine. Maybe the person associated with that machine doesn't realize that their machine was part of a botnet, a bot army. They've now picked up their laptop and they've moved to a Starbucks because they think that the corporate network is down. Now, if we just allowed them to move to another network, potentially they could then log back into the corporate network via a VPN tunnel, and unbeknownst to them, the hackers now got a backdoor back into the environment and continue their nefarious activity. Now, a couple of things here. Let me just come back here, and you can see that there's a countdown timer here. Let me just refresh that. It's got 2 minutes. So what I'm actually going to do here, and there's a very good reason why I've got this open, is because I'm just going to keep this here for a second, and then I'll get back to the because. So what I'm going to do here is I'm going to unquarantine this machine, and this would be an example of where the administrator would look at this and say, well, actual fact, I know what was happening. It was actually the IT department ourselves running a scan, just doing our due diligence. So this is a false positive. So what I'm going to do is I'm going to unblock that. Okay. So now this is going to initiate the manual unquarantine. So if I come here and I refresh this, that quarantine is gone, and all of a sudden I can ping. All right, now notice I've lost complete control of this machine. There was a couple of pings there that went through, but now I've lost. This is dead as a doornail. So let's go across here to my ESXi server, because that was a virtual machine, and you'll understand now why I lost that. Notice here that the FortiClient has gone into a quarantine state. That users picked up their laptop, they've thought, hey, I can't work on this corporate environment. Something's not right. Maybe the IT has done something. I need to get my work done. I'm going to pop down to Starbucks and get on that Wi-Fi. But in actual fact, the threat hasn't gone away. The threat is still attached to that machine. So what I've done here, within my automation scripts, and this is the power of the Fortinet fabric, if I look at my automation scripts here, I've got another script here that basically says, if I get a trigger coming from that webhook, the original block webhook, then perform a secondary action, which is to quarantine that user under the FortiClient. So now I've got integration with my Fabric connection. The FortiGate is connected to the EMS. The FortiGate is communicating with the EMS. The FortiGate now sends a message to the EMS to say, hey, don't trust this guy. Please quarantine him. I don't care where he or she is. Take them off the environment. Now, the reason I lost this is because I've got two interfaces here. I've got the interface used for traffic going out to the internet, and I've got the interface that I'm using to VNC to this machine. FortiClient blocks them all. It's not giving any backdoors to allow the bad guy out. So what I'm going to do here is I'm going to log into the EMS server, and just give the relevant password here. Okay, it's logging in. Never mind about that. And if I come to my endpoints, I can see here I've got one that's been quarantined. All right, there it is. There's its IP address, so I know that's in a quarantine station. So now I'm going to release that, unquarantine that. Now, it's going to take up to 30 seconds because that's the window in which FortiClient connects back to the EMS. There you go. It was under the 30 seconds. So now this machine can communicate again. All right. It's now connected. That quarantine has disappeared. So hopefully that shows you how we can not only identify a malicious user on the network using the deception technology, but by enhancing the greater fabric, we can ensure that that threat doesn't spread elsewhere across the network via different avenues, like I said, e.g. using a remote access to get back into the environment. All right, it's a complete end-to-end security control environment, an ecosystem. We call it the Fortinet fabric. It helps us control and manage threats irrespective of where they're coming from or where they might be going to. So thank you very much for watching, and I bid you farewell. Thank you. Bye.